Hello, everybody. Welcome to our RAG Hack live streams.
RAG Hack is a free global hackathon happening from September 3rd to 16th. RAG is a technique to get a large language model to answer questions based off your data. We have more than 25 live streams teaching you how to build RAG apps with different Microsoft technologies, plus 10 cash prizes for the best RAG apps in each category. So we're super excited to have you join us for this RAG Hack. And now a word from our friends at Reactor.
Hi, everyone. Thanks for joining us for the next session for our RAG Hack, Building RAG Apps with Azure Cosmos DB for MongoDB. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and our presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and looking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenters. Khelan, John, thank you so much for joining us today.
Welcome, folks. My name is Khelan Modi, and I'm a product manager on the Azure Cosmos DB team. I'm joined by John Aziz. John, do you want to say a couple of words before we get started?
Yeah, thanks, Khelan. Hey, everyone. I'm John, and I'm from Egypt, and I'm working as a software engineer at Fabrica, and I'm currently an AI MVP.
Sounds good. Okay, let's get started. So today we're going to teach you how you can build RAG applications with LangChain and Azure Cosmos DB for MongoDB. So the brief agenda for this session is going to be, first, I'm going to be talking about what is vCore-based Azure Cosmos DB. I'm going to go over a couple of technologies like Azure OpenAI and LangChain that we'll be using to build such an application. Then John's going to have a wonderful demo for you where he's going to walk through the code in the Jupyter Notebook. And finally, we're going to end with a bunch of links. If you want to follow along, you can check out the demo code at aka.ms/vcore-langchain. You can also run the GitHub repo in code spaces, or if you want to run it locally, the steps have been listed in the README file. So follow along. So what is vCore-based Azure Cosmos DB? So Azure Cosmos DB for MongoDB offers a fully managed MongoDB compatible service, especially designed for developers to build intelligent applications. Since it is a VM-based architecture, it allows the flexibility to either scale up horizontally or vertically to accommodate the requirements of your workloads. What's great about vCore is it transparent pricing. We are charging a flat fee based on the actual compute and storage that you're using for your application. Additionally, we have a free tier which allows you to provision a vCore-based Azure Cosmos DB for MongoDB cluster with 32 gigs of storage forever. So by integrating the well-established MongoDB framework with the Azure ecosystem, we are able to give you the best ecosystem possible to build your GenAI applications. But why would anyone use vCore-based Azure Cosmos DB? So when users can only have one database for their operational as well as the transactional data along with their vector data. It's an all-in-one database. So you're going to save on cost and complexity. For example, if you're using a third-party single-purpose database such as Pinecone, you'll have to ETL your data out of the transactional data store, put it into their database, and surface that for vector queries and RAG pattern, and then bring the data back. However, this method has some limitations, right? Because if you have a highly volatile data, your third-party databases aren't best suited for such rapidly changing information, because there's always going to be a lag in updating and querying the data. This delay means that you're not analyzing the data in real time, and by the time you're analyzing it, it's already outdated. So therefore, going with a first-party service is going to give you a best experience with real-time AI, which is going to be quite straightforward, and it's potentially going to cost you less and give the best integrations with other Azure services. Also, with Cosmos DB's multi-region write and capabilities with advanced indexing like IVF and HNSW vector indexing, that means that you'll be able to build your RAG applications with low latency across the globe. So if you have structured or semi-structured data, semi-structured operational data together in one place, Cosmos DB is the place for you. But however, if you have structured or semi-structured data from a variety of sources, internal or external, Cosmos DB might not be the right fit for you. So if you have a single source of truth, Cosmos DB allows you to do a vector search with inbuilt vector indexing. But if you're looking for state-of-the-art technology like hybrid search, fuzzy search, autocomplete, or re-ranking, you might want to use something else. But we are working on those features as of now, and they'll be coming out soon in the next couple of months. So if you're building a Bing-like search experience in a custom application, you might want to use something else for your RAG application. So if you want to get started with Azure Cosmos DB for MongoDB, again, you can go to the link at aka.ms/try-vcore, and you can provision a free account right now without the need of your credit card. So now in this demo, we'll be using a couple of Azure OpenAI technologies, which is the first one is the chat deployment. So chat deployment refers to AI models like GPT for like conversational driven applications. These models are designed to understand and generate like human-like responses. So in the image that you see on the screen, the user is going to ask, so it's going to say a simple response on hey, and then you'll get a response back from the system message. John's going to be covering multiple roles that we'll be going through in this demo later while he's going over the Jupyter notebook. Then we have the embedding deployment. So what embedding deployment does is it translates a piece of text or data into a bunch of numbers. So what these numbers represent is the semantic meaning of the text that you have. This text can either be data in terms of words or numbers or images, anything like that. So instead of searching for keyword-based search, using the vector embeddings, you're able to search via the semantic meaning of it. So when you're combining both the chat deployment and the embedding deployment together, you'll be able to create chatbot type applications where users can find the relevant information for like recommendation based applications or like detecting based applications or whatever. Finally, we'll also be using LangChain. So LangChain is a framework for developing applications that are powered by language models. So by combining LangChain with Azure Cosmos DB for MongoDB, you'll get the fastest retrieval along with data storage, also providing real-time insights. So briefly going over architecture for our demo today. So for example, if you have a bunch of documents, right, your documents are going to be chunk documents. We're going to send them to an embedding models, which is going to create the embeddings. For reference, embeddings are a list of numbers which represent the semantic meaning of your data. Then we're going to store your embeddings in Azure Cosmos DB for MongoDB vCore, along with your operational and transactional data. At the same time, a user is going to ask a question like, give me a high protein recipe. What we're going to do is we're going to take that question, again, go through the same exact embedding model, and going to create a vectorized prompt. Once we have the vectorized prompt, we're going to go into our database, which has inbuilt vector indexing, which allows us to find relevant information in really fast time. Once we find the information, we're going to come back and give the user the response. Additionally, we're going to store, the next time the user asks a follow-up question, we're going to store the prompt history again in Azure Cosmos DB for MongoDB vCore to give you more personalized answer the next time a user asks a question with more follow-ups. So let me now go over to our website where we'll see this in working. So here I have a Cosmic Food RAG application with different kind of developer settings. So let's look at the developer settings that we have enabled right now. The first one is the temperature. So right now the temperature is set to 0.3. What a temperature means is like how creative do you want the LLM to give you the answer? If you want to like strictly stick to the answer that's in the database, we can switch that. Either up the temperature to 1 or 0 based on your needs. Then we have the similarity score threshold. Like how similar do you want the responses to be based on the questions that were asked by the user? Right now I've saved it at 0.5, but obviously you can take it up to 1 or 0.8%, 80%. Then we have the retrieval mode, like how many results do you want? Finally, we have different retrieval modes. The first one is a keyword search. So if I do a keyword search, and ask for high protein recipes, it's not going to give me any responses because in our data, we don't have any data points which has the word high protein in it. So this is where vector search comes into play. So if I ask the same question again, what are high protein recipes? It's going to go into the database and look at the responses, look at the data and give me responses based on it. As you can see, beef udon noodle soup is high in protein because it contains beef slices and it has eggs as well. But
Can you click on the bulb before we move on? On the bulb, on the right top of the first one, to see the steps. No. Just on the message. Yeah, on the message itself.
Yeah.
Yeah. The other one, the sort process. Yes.
So
all of these were returned, and they were matched by vector search, and then we choose the top one or the top result from all of the results that got returned from the database, and we give it back to you at the end. I guess if you scroll down a bit. Yeah, that's the source. Okay. Now,
as you can see, you can also look at the source where the data was retrieved. Yeah, go ahead, John.
Yeah, you can try the third one to see. I guess if we want to ask it, what about something else other than that? Let's try that with Victor first and see if it will work.
Okay, can you give me a question to type in the chat?
How about what about shrimp?
Okay, let's see.
Or how about you try something else? Something else, because we don't want to give it like. How about something else? Will this work? Oh, it does.
It does work. Yeah.
But it's irrelevant, I guess. It's irrelevant to our question.
It's relevant to the previous prompt that we had about high protein recipes. It was able to give us a salad, and I feel like this is where RAG comes into play because this is just doing a simple vector search of what the results are there. So if we change the developer settings to RAG with vector search and also enable the streaming chat, which allows you to see what the LLM is going to type at the same time. So let's clear the chat again and ask for high protein recipes. So now it was able to give me a green goddess Cobb salad with chicken, but I can be like, John, what do you prefer? Do you prefer shrimp or something else?
Yeah, shrimp.
Okay. What about shrimp? Okay, let's say I prefer.
Oh, it does work.
So as you can see, when we said I prefer shrimp, it was able to see that our previous question was about high protein recipes. So that's why when it recommended me a new recipe, it was able to mention that a shrimp tempura udon noodle soup is a delicious high protein option. So this is where RAG comes into play. It has like previous context about the previous questions that were asked and the answers that were given, and we are storing them in Azure Cosmos DB for MongoDB vCore. So I'm going to pass it over to John to briefly go over the code and what the steps are.
Yeah, let's see something else before we move forward. How about the steps for this one? So let's click on the steps here. And it's the bulb, the light bulb at the beginning. It will open it directly. The issue is that you are streaming the response. So I have not yet implemented it for streaming. Can you disable streaming and try to ask it something?
Okay, let's try it again without the streaming.
Yeah,
as the same question.
Now can you click on the bulb or the light? Yep. Now this is the rephrased question. So that's the steps of the RAG that we do. First is that this is the query that someone asked, which is what high protein dishes are available. And then we sent it to Azure OpenAI to be rephrased. And yeah, it got the same question because we are rephrasing like only one question. And then it got all of these responses from the vector database. And if you scroll down a little bit, it sent all of these things to Azure OpenAI and got us back this rephrased sentence. And all of that is done using this content that we retrieved from the database and some prompts that we wrote to instruct the LLM to act a specific way. can you ask it something else to make it like to make the rephrasing actually stand out? So
Yeah, I'm gonna ask the
prefer
same
something
question
else.
again. I'll be like,
Or
I prefer
shrimp,
shrimp,
yeah.
and let's see how it goes.
What high protein dishes available with shrimp? So now he's actually asking, I guess, yeah, the rephrasing works kind of, but it really stands out when you try to ask it something that you don't give it context about. So you might try to ask it, how about something else? Can you try?
Okay. How about something else? Let's see how it goes.
Okay, cottage cheese tikka. So you asked it, how about something else, and it rephrased it to what other high protein dishes are available. So yeah, it does rephrase the question, but it depends on what you're talking about. So we started with what high protein dishes available, and then when we ask for something else, we're gonna get other high protein dishes available.
I feel like that's where the context comes into play, right? We said
Yeah,
the context of the first question and just is going to follow along with those contexts. Yeah, that
yeah,
makes sense.
and it really helps because if you just ask it all about something else, it's not gonna know what you're asking about if it doesn't have context of your previous messages. So I guess now we dig into the code to see how all of this happens. Oh, you can see my screen now. From what you can see, this is the sample that we shared the link to. I think it was shared previously in the chat. It's aka.ms vCore LangChain without any dashes. And if you open it in code spaces, yes, that's the one. Thank you. If you open it in code spaces, you will get everything set up. You don't need to install anything, but these are the requirements for running this notebook, but you don't need to run this step. And the first step is that you would actually need to activate your virtual environment. So we do provision a virtual environment for you when you create it inside the code spaces, but you will need to activate it inside this notebook. So after you choose this, we will load our environment variables. And all of these environment variables we got from creating the Cosmos DB database and Azure OpenAI resources, Azure Cosmos DB for MongoDB vCore, and that's it. Yeah, all you need is the two things that Khelan mentioned in the slides earlier today, and that's it. We just run this code to load it, and we initialize the client. And what we are doing here is that we are saving some global variables inside OpenAI, so we don't need to send it every time we try to make a request to do something with it. And all of these global variables are going to be sent back and forth when we try to use anything with LangChain. If you can see, all of that is like, it's the OpenAI type, which is Azure, the endpoint, which is the URL of our endpoint of our provisioned resource on Azure. And this is the API version and the API key. So all of these things are things that you would normally need to interact with OpenAI resources. And after we do initialize this OpenAI stuff, we are gonna initialize the Mongo client with our secret and connection string and so on. After we do initialize these secrets and we initialize a new client, and if the database doesn't exist, this is the database name. If it doesn't exist, this piece of code will actually create an empty database with the name that we supplied with. And then we have a little function to parse our JSON lines or this JSON file. If you go to the data, these are the food items. Yeah, it might look like JSON documents and unstructured data, but at the same time, we do need to parse it in a specific way to be able to query it with LangChain. We actually need to initialize a document, and this document is what they return when they query the database. So it needs to be in the same structure as the document type that they have. And that's why we need to read every line of this JSON file and save it in an array, and then we might do something with it, like store it in Mongo. After we do this step, I guess I didn't do it, so let me just run this one. This one. This is our JSON line, and this is a sample from the data that you've just seen. After we do that, we will initialize the embeddings client. In order to do that, the only thing that we need is the model name and the deployment. Normally, we would need to specify the endpoint and key here, but because we did it globally up there, we don't need to do it again. After we do that, how to activate, after we do that, we can run this step, and then we can generate and save the embeddings to Mongo. But in order to do that, we need a specific index, because Mongo doesn't come, MongoDB doesn't come with search enabled by default. You can search for IDs, but you can't search for text unless you create an index to search for the data inside it with a specific type. So, for example, we have text index, and here we have the HS and W index, I think, that Khelan talked about. And you can create it with the IVF too. So after we do this step, this is going to generate the embeddings and save it to Mongo. So I'm going to interrupt it because we already have the data saved there. And if we run it again, it's going to add new data to Cosmos. Now, this one is just so I can have a client to communicate with Mongo. So LangChain has two different classes. One called Azure Cosmos DB vector search from documents. This one is the connector for Azure Cosmos DB for MongoDB databases. But you can either use from documents, and this will create a new document in the database, populate it with the data, and return a client that you can use to do retrieving on the database. Or if you already have done that, you can use from connection string. So you are able to connect to the database and have a client that you are able to use to retrieve the data without recreating the data again. Now we only need to run this one, so we will run it. And this code is not, we don't need it because we have already provisioned our HNS W index. But if you do it again, it's not going to do anything, because it's going to tell you that the index already exists. Then we can do RAG. As you can see, let me just minimize that. We don't need it. If you see here, all we have is a query, and then we use a function called similarity search from the vector store, which is the retriever that I told you about. So if you say vector store dot, you're going to see that there are, I guess, lots of things for search. So there is the async similarity search by vector with relevance score, with a score, but we are using the similarity search one that takes a text input. And then what it returns is a document. If you remember, I told you that LangChain uses documents. So it will return a document. So we need to access the list of documents dot page content. The page content has the data itself. And there is also something called metadata. But let's see the page content first, and then let's see the metadata. If we try this one, we are accessing the first result returned to page content. And this is the document that we saved to the database.
One thing I want to point over there, John, just want to point for the audience is when we do like vector store dot similarity search, the documents are like sorted by the similarity score. The higher the similarity score, it's going to be shown up above the list. So when it says document 0, so the one with the highest similarity score is always at the top.
Yes, that's why we are choosing the first index for the array that it got returned. And if you look here, this is the metadata. Why are we accessing the page content? So the way LangChain does it is that they store the actual data inside something called page content. It's a string. And the metadata which can be anything. It's a dictionary, and it can be a key value pair of anything that you want. They store it in the metadata property. So this one has everything. So the vector embeddings that got generated when we stored this document in the database, and all of that. By the way, we passed something. When you use from documents, it's actually going to do two things. It's going to call up Azure OpenAI embeddings endpoint, and at the same time, it will do some stuff with the database. So it does two steps. This function does two things. It generates the embeddings by calling Azure OpenAI, and it sends all of these documents, data with the embeddings to be stored in the MongoDB vCore. So that's why it's good, but at the same time, it's very it's very dangerous to run it twice. So only run this one first time, because it's gonna store the data and generate the embeddings when you run it again and again and again. And yeah, Khelan, can you tell us anything else we can search for in the Mongo database that we have?
Can we do something like a smoothie, like a high protein, or like some like protein recipes? And also, I saw in the chat that people are looking for vegan options. So let's also do a vegan option search if possible.
Oh, I'm not sure if a vegan option is gonna return it. Oh yeah, we have it in the description.
I think we do. We
about
do have
vegan. Yeah.
vegan. Yeah.
We have something is vegan. Okay, so sandwich beyond burger, and it's served with Romanian lettuce, tomato, pickles. Ooh. I think I just went back one page. So wait. Okay. While it does do that, we can.
I want to answer the
see
question that we got in the chat. Does it have semantic search? So we got a question in the chat, like, does it have semantic search? To give you a context, yes, when we do like a similarity search, right now we're using cosine similarity to get our output. So the closer the results meaning is to the question that was asked, like in this example, it's going to be about vegan options. The closer it is to the results that we have in the database, the more similar it is semantically, it's going to show up in the as the first output in our sample, in our demo.
Yeah. Now we do get to this one. This is the one that we were talking about. So this is beyond burger and served with lettuce and mayonnaise, and this is the price, which is $9. Does it do keyword search? Does it, Khelan?
We have like simple keyword search support with Azure Cosmos DB for MongoDB, but you cannot combine the keyword search with vector search as of today.
Yeah.
But in a couple of months, yes.
Someone is saying that mayo isn't vegan. Isn't there a vegan mayo? It says vegan mayo. So I guess it's, I don't know. Okay. So yeah. Let's move forward with the other one. There is vegan mayo, yeah. That's great. So now after we did explore how to do searching with the vector search, and all we do is just we call this function. It's going to return the documents, the top documents from the database that you saw. And then we can choose the first one and return it to the user. After we do that, we get to do some stuff with rephrasing and responding in a human-like way with the chat deployment. And again, all we need to do is to get the Azure Chat OpenAI, to get our model name and the deployment name, to create a client with them, and to use this chat client. And again, just like the embeddings client, normally you would need to supply the endpoint and the key here. Or if you want to go keyless, I think they support keyless auth with AD tokens. Yep, they do. But for now, we are not using keyless auth. So now, I guess we can ask it to tell us a joke. Why did the tomato turn red? Because it's so with salad dressings. Yeah. I don't know if this is funny or not. Just laughing because I'm
Not
so
the funniest joke, but yeah, it get the
Yeah.
context. As it's an LLM at the end of the day, it's not gonna know what's funny, but
Yeah. Can I ask it something else about our data?
about our data, let's ask. I think we had a question about smoothies, right? Let's ask something about smoothies. I don't know.
Yeah.
You can ask for like dinner recommendation, like breakfast recommendation with smoothies, something like that.
Okay.
Or we can get questions from the chat if they have any.
Recommendations. Yeah, if you have any questions, send them in the chat. Yeah. So it has green smoothie, just banana berry smoothie, mango pineapple smoothie, and lots of other smoothies. But these stuff are not returned from our data. And again, this response is not like the embeddings one, because this is not returned from our database at all. So it's going to have a different structure. And we can actually see it here. If we try, it's going to have the content, and it's going to have the stuff that's related to the guardians of the content filters and the maximum tokens, the model name, the stuff that you would normally see in a response to content filters stuff, and so on. So this is the actual Azure OpenAI response, but they built it inside this object, and we get to use the content from it.
And also, do you want to briefly cover like how chunking is done with our documents? So I see a question in the chat. Someone asked like how the chunking is done, and is each JSON entry put it into a separate chunk?
Yeah, each JSON entry is put it into a separate chunk. We don't do chunking because we don't need the chunking for the JSON documents, unless it's an like we do need the chunking when it's like beyond a certain size of a JSON document. So if we do exceed the size of a document, we will need to chunk it. And I think the most straightforward approach is that we have a reference ID if we chunk the data. So we have the main document, and then another document that references the original document. So we know that this is the same document that we are talking about. But other than that, we don't do chunking. Every JSON entry is put in a separate document, JSON document in the database. And we can see it actually with this one. So I think you can see my screen now. This is the database. These are the documents. And this is an example document. So it has an ID, has the text content, and the vector content. So all of these things are the content of our vectors. If you look at the text content, I guess we aggregate all of the JSON and convert it to a string, and then we store it there. Integrated. Someone is asking another question, Khelan. Can you?
I'll take that in the chat. Yeah, I'll respond to that question.
Okay, so now we can move forward and try something else, which is how to do streaming in LangChain. So LangChain has a specific function for streaming, and it returns an async iterator. So it returns an iterator, not a generator. So we'll need to iterate over it and print the content inside it. As you see here, it's very simple to use, very straightforward. Just use a stream and then give it a message, and it's gonna stream the responses. So as you see, it's printing the response as it's getting generated from Azure OpenAI. And now That's the last part in our vector exploration and the RAG preparation. Now we get to do RAG. So in order to do RAG, we need prompts to instruct the LLM to behave in a specific way. And our two prompts are the rephrase content prompt, which rephrases the whole chat history into a single message that we can use to query our vector database. And the other one is the context prompt, which basically takes everything and responds with a single response to the user at the end. So the context prompt will take the context, which is the chat history, all of the messages that got sent before, and then it's gonna take the user input and give us a chat response at the end. And if you see here, in order to use Azure OpenAI with in this settings, we had to create a retriever. So we had to create this retriever, and in order for us to create a retriever, we limited the responses to 3 responses, and we have a score threshold for the search. So this is if a response matches the question that I'm asking, what is the threshold that I'm gonna evaluate based on? Is it like a 50% match, 90% match? We have set it to 50%. And this is the search type, because we have vectors, we are doing similarity search. So this is the retriever from the database that will return the documents from. And then LangChain has a special way of creating chains. And we do that by using the pipe operator. And this pipe operator normally would represent OR in Python, but LangChain overrode this function, and they created a function that returns a runnable function that you can use to invoke the LLM and do stuff with the LLMs using this prompt and the client, the OpenAI client.
Wait, so
And
can
we
you
have to-
explain what's happening over there? Like, why do we have the pipe symbol between like rephrase prompt template and the Azure OpenAI?
This is a function. This is a function. It's just like calling or and then giving it this and this. Not, but yeah, it's just like calling the or and giving it two things to do or between, like that. But then instead of doing it like that, it's a function that returns an object response. It returns something called a runnable, and that's how they call it. And this runnable is gonna be, we are gonna be able to use it to invoke it and to interact with the LLM using this system prompt. So using these prompts that we talked about earlier, that rephrases the question and summarizes the content and responds based on the question, we are going to be able to use vector search here using this retriever and this chain and the other one to get the context. So if we do run this code, did I run it or did I not? Just in case, we have our RAG flow ready to be used or ready to be tested, I guess. So this is a message. It's an array, and it has a content and the role. And it's a very simple message, as you can see. Do you have any vegan options? And we are first gonna do the first step, which is rephrasing the question. And this is just gonna give us a question that is, I guess, similar to the question that we just asked it. And like you see, it just rephrased the question a little bit. So it's not doing much now, but it's gonna do something when we have a chat history.
Can you briefly
And then-
explain the different kind of roles that we have? I know we specified the role user, I know we have like
Yeah.
other roles too. Can we go over them briefly?
Yeah, sure. We have the assistant role, which is the
Mhm.
LLM itself. It identifies itself as an assistant. And we have the system role, which we use to send these system messages or the system prompts or the initial prompts that instruct the LLM to behave in a certain way. And we have the user ones, which is us sending messages to the LLM. So it's able to figure it. So the LLM is able to figure out which is the system prompt, which is the messages that it generated, and which are the questions that the user asks. So again, like we said, we're gonna access the content which has the response from the LLM. What vegan types do we have? And then we can take this rephrased question and invoke the database with the function called invoke. All of them are called invoke, by the way. So we're gonna invoke the database, and that's it. It's gonna return the vector context. There is one issue with the return of vector context. It returns the vector document or the documents with the embeddings, and we don't need the embeddings anymore. So what we're gonna do is that we're gonna format the returned response and remove the vector embeddings from it. So it's not huge, because if you saw before, if you remember, I showed you the vector is like very big. So now this is what we have. This is a document from the database. And so we did two things. We rephrased the question. We got some documents from the database using that question. The last step is that we send our original question or the rephrased one to an LLM, and we send this documents from the database. Yeah. Some people are asking questions, I can see.
No, that was just Pamela like explaining what we have. It's okay.
Oh,
fine.
yeah. To chain function calls together, yeah. Now, I guess we can use this one. Oh, we have a delicious Beyond Burger made up with mayo, ketchup, and chips. We also have tofu salad sandwich with vegan mayo and so on. So that's, I guess, what it returned from the database. And this is what we rephrased with LangChain. Yeah. Thanks, Pamela, for jumping in. Now, this is where the rephrasing stands out in our like small demo. If we do append some messages and we have a message history, we can try to ask it again with our previous messages and our new message. What is the price of the first dish, for example? And let's just return what is the first dish. The first dish is the Beyond Burger. Okay. So now if I ask it what is the price of the first dish, it should be able to know that I'm asking about Beyond Burger, and it should be able to respond based on the database document that we have for Beyond Burger. Now let's print it. So it says, what is the price of the Beyond Burger? This is our rephrased question. It passed this one. And then the price of Beyond Burger is $9, which is correct. It's with Romanian salads and lettuce and so on. Now we have the last step, which is the inline embeddings with Khelan, I guess.
Yeah, I think someone had a question about how if you can create embeddings, automatically create embeddings. So this feature is, we're currently in the testing phase. We should have something announced in a couple of months where you can just use the generate embedding function, and it's going to create either update, or when you're adding a new data into your database, it's going to create the embeddings for you and store it along with your operational/transactional data. So stay tuned. Our Azure Cosmos DB social team is going to post about it on LinkedIn, Twitter, and a bunch of other places.
Yeah. And because we still have some time, we had some stuff that we didn't show in the notebook, and I think it's time to show it. So here is the keyword search. Someone asked about keyword before, and if you do remember,
Yes, we do have the keyword search. So over here, as you can see, we use the search field in the text on line 11, where we can ask for keyword-based searches, and it's going to do it for you. But
yes,
soon you'll be able
and
to combine it with vector similarity search and to give you a better response in the future.
yes, and we did that by creating a vector a full text search index on the database. So we cannot do that without, I think, creating the text index here, this one. So we call the ByMongo client to create a text index on this database. So we are able to do keyword search on it using the, again, ByMongo client. We just send it the $sign text, and then we give it a search, and we give it the query and limit it to a specific number of responses that we need. And then because we want to follow the same structure, we format the returned data in a document, in a LangChain document. So everything is the same. And yeah, I guess, yeah, there is a difference between the RAG and the RAG with streaming, because of course this is streaming the response, and that's why we are not returning the rephrased question with the RAG streaming at the same time. And by the way, if you go back to the notebook, this is the code from the notebook. We just wrapped it in functions, and we are calling the functions, whether it's for streaming or for just running a simple query over the database. So this is the same stuff that we did. We have a prompt, we chain the function calls, and then we do the responses returned here. Yeah, thank you.
Okay.
That's it.
So thank you, John, for going over the code demo. Now let's briefly go over to my screen and let's talk about.
Khelan, I forgot something. Yeah, if you want to add your data, yeah, there is a script for adding the data. So let's review that. So it's easier for people to do. If you want to add data to Cosmos, there is that script or this script, and you just need to run Python /script add data with the file, and you need to run it in an environment where you have access to Cosmos and all of that. This is the simplest script. It's running the function that's called from documents, sorry. And it's just reading the JSON data like we saw in the code in the notebook again. And then we are using from documents to call or to generate the embeddings and populate the database. So if you do have JSON documents just like ours, this one, all you need to do is to use this function, but just make sure that no, you don't need to make sure of anything. Just use it. It's gonna take all of that and store it in the text content in the database. So it's gonna take each document, chunk it or make it like one string, and then generate the embeddings on it. I just want to show you this here. Yeah. So it's going to take the document, the category, the name, the stuff that we saw in the JSON, store it in a string, and then store it in something called text content. And then vector content is going to auto-generate it for you with the vector embeddings for this data. So it's going to automatically embed the data in the database with the vectors. Yeah, that's it. Yes.
Thank you so much, John, for showing us the code. Obviously, there's a lot to go. There's a lot that goes behind the scenes. So if you want to check it out, check out the demo code at aka.ms/vCore-LangChain. And if you're interested to look at other samples that we have built for Cosmos DB, you can check it out at aka.ms/Cosmos AI samples, where we also have documentation on how you can get started with Cosmos DB to build your Gen AI applications. Also, if you have any questions, feel free to put in the chat. I know we have like 10 more minutes. We'll try to take as many questions as we can and answer them. Yeah. Thank you very much.
Hi, everyone. Hope you enjoyed today's session.
If you aren't registered yet for RagHack, you can register now at aka.ms/raghack/register, and you can introduce yourself on our forum. You can start hacking either by looking at one of our code samples or just starting from scratch. If you have any questions along the way, feel free to post them in our GitHub discussion forum, and you can also attend live office hours in our Discord. Once your project is ready, make sure to submit it before September 16th at 11:59 p.m. PT to be eligible for our cash prizes. And of course, make sure to join our upcoming live streams to learn more about RAG. Thanks for joining.
Thank you, everyone, for joining. Thanks to our speakers. Feel free to continue asking questions in the chat. We'll be here for another 9 minutes. If you want to learn more about the series, you can follow the link at the bottom of the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat. Today's event code is 23329. We'll see you at the next one.